See on this Unit 3 review sheet that a handful of blocks, specifically the bottom right-hand corner, and if you flip over, 2 in the middle and 1 in the bottom right-hand corner, are crossed out, not because that's not relevant, just that those pieces are not relevant for tomorrow's test.
Oh wait, do you have our previous assessment?
Can't miss this.
Chart in the upper left-hand corner asks you to calculate the marginal product, and then on the right, plot the total product and marginal product on the graph. I'm going to just recite the marginal product. For 0, there's nothing, so this is a dash. The first worker adds 5 units of production. The second worker adds 10 units of production, then 4, then 1, then 0, then -2. 5, 10, 4, 1, 0, -2 are the marginal products, and that's just the difference in production. Marginal product, change in production for a change in workers.
And then diminishing marginal return is when
Then-
you add the 4th worker.
Then it asks you to graph these, and you can go through and put tick marks in, but there's a brief piece of increasing returns to production based on efficiency. Then we have our normal decreasing returns, and then because the 6th worker takes away 2 units, not because they're disruptive, not because they're a bad worker, there's just nothing for them to do, so they're bumping into people and whatnot. There's negative returns. And this is total production. Marginal product is 5, 10, 4, 1, 0, negative. Something like this. And that's just me plotting those points. Define the law of diminishing marginal returns. As variable resources are added, the additional output from each new worker eventually falls. That's diminishing marginal returns. Given a fixed resource, or a fixed resource, adding variable resources will eventually result in output from each new worker to fall. After which worker does diminishing marginal returns set in? Marginal returns from 0 to 1 is 5, goes from blank to 5, that's increasing. Then it goes from 5 to 10. 5 to 10 is an increase. From 10 to 4 is a decrease. So after which worker does diminishing marginal returns set in? After the second worker.
Oh, because it gets
After the second. Wait, did you do the definition of diminishing margin?
As variable resources are added, output for each new worker eventually falls. And again, all of these definitions are printed on this sheet that I actually hit file a print on our campus. I'm going to fire through revenue and costs, knowing that you have a ton of resources to get this fully filled out if you miss something. Total revenue, price times quantity. accounting profit, total revenue minus explicit costs. Remember that explicit costs are like checks that you have to write. If I work at my lemonade stand, the costs are the lemons, the sugar, the water, the building, to rent the space to sell, etc. Those are things I have to buy. But also, my time of working there. I could be doing something else that I'm missing out on. That's an implicit cost. Economic profit is the total revenue minus both explicit and implicit costs. I'll-
What's an example of
My time. So the example I just of the lemonade stand, the things I write a check out for, like the plywood to make my stand, the pouring thing, the cups, the lemons, the water, both the fixed and variable costs, and my time, specifically the fact that I could have been doing something else. Just if you need another piece to review, remember in class I noted that in like the second and third pages of chapter 13, there's a little story about a person named, I think her name is Caroline. She makes cupcakes, but she also has experience as a computer programmer, and as the opportunity costs of her time change because of the wage she could earn as a computer scientist, her implicit costs change and help change her decisions. So that's like a good 3-minute read to help differentiate explicit and implicit costs. I'm going to come back to normal profit after. Fixed costs, costs that don't change as you produce more. Be ready for fixed and variable costs to be able to come up with examples. Variable costs, costs that do change as you produce more. Fixed cost examples would be like rent, insurance, the machines. Variable cost, wages to workers, like the raw materials. If I'm doing my lemonade stand, the plywood for the stand, the stirrer and the bowl to mix the lemons and water, etc., and the pitcher, and the little box that I keep my money in, all fixed costs. I need to buy them once, whether I produce 5 glasses of lemonade or 100 glasses of lemonade, it's the same. Variable costs, wages for anybody that has to work for me. If we're going to produce 200 glasses of lemonade, I probably need someone to work with me. Raw materials such as cups, sugar, lemon, water, ice. Total cost is the sum of those two. And marginal cost is the additional cost to produce one additional output.
Wait, that's total
The
cost?
additional.
Total cost is the sum of fixed and variable. And marginal is the additional cost to produce one more output, one additional output. If you have a pencil, where you have a pen and conviction, why don't you go ahead and draw and label the average total cost, average variable cost, and marginal cost in the bottom left-hand corner. Give you a hint, that's not it. why does marginal cost go down and then go back up? Marginal cost goes down because it returns to scale / efficiency. The fact that you're getting a little bit better at making lemonade just by getting more like reps and you start to get some muscle memory, etc. Think of like the marginal cost of time and effort to learn economics. To learn like a little bit, you start to learn like the vocab and it gets easier and easier and easier. And then you hit a point where you're gonna put in like a ton of time to learn like all the little like subtleties that go into each piece. For instance, there's like classes just on like the theory of the firm and whatnot. They would spend more time and effort just to dig deeper, etc. This is marginal. Marginal is the cost of the next one. Average, though, is a little bit different. Average takes the total cost and divides by how many you produce. Well, at first, the average is pretty high because if you make one glass of lemonade, I had to pay $100 for the plywood to make my lemonade stand. I had to buy the bowl and the spoon. I had to buy the pitcher. I had to buy the thing my money goes in. I had to spend $500 on all those materials, and I'm only making one glass of lemonade.
The total output
Nope, the total cost.
divided by.
Average cost, right? So the average cost for my 1 cup of lemonade is $500. It's pretty expensive. But if I make 5, now I'm dividing that $500 plus, the cost of, getting the variable costs for making lemonade are pretty low. A lemon's like 50 cents. A little bit of sugar is probably like irrelevant, not very much. Water's not super expensive, so it's like under $1 for the variable cost for it. So now my total cost is divided, $503 or whatever it is divided by 5 glasses of lemonade. 500 divided by 5, or 500 and change divided by 5 is about 100. 100 is less than 500. Now if I make 50 glasses of lemonade, 500 and change, maybe $520, whatever, divided by 50 is 10. Now my average cost per glass of lemonade is $10. What's happening as I produce more and more and more? That's going down, right? If I produce 1,000 glasses of lemonade, if I produce 1,000,000 glasses of lemonade, I'm not really caring about the $500 that I spent for my lemonade stand. That's the fixed cost, but there's also this idea of average total cost is decreasing because the cost of making the next one is lower. Remember your average in a class and your marginal grade? If marginal or the next one is lower, it's going to bring down your average until you get to a point where they're equal. This is the bottom of the average. And now what happens? The marginal or the next one is higher. Average variable cost follows the exact same concept. Average variable cost but at the end they're pretty close to the same thing because the average fixed cost goes super small, and this plus this is this. This is super small, so this plus this is there. This is sort of big, that plus that is that.
Explain why the average total cost goes down.
2 reasons. One is because the next one's lower, so it decreases the average. Right? The next one's lower, the marginal is the next one. The next is lower, brings down the average. Next is lower, brings down the average. Next is higher, brings up the average. The next is higher, brings up the average. The next is higher, brings up the average. That's more like a mathematical explanation. Another explanation is because of decreasing or diminishing marginal returns, the cost, when we get like over here, like why does average cost end up going up? Because that variable cost of trying to make one more gets really hard because in my lemonade stand, given my fixed resources, how am I gonna make 1,000 glasses of lemonade? It gets harder and harder because if I hire another person, and we can get away from my lemonade stand and think back to the coffee case study, adding an 8th barista to Starbucks, you pay them $10 an hour, but they don't add much production. So to make one more cup of coffee, when you're already producing 150 cups of coffee, to make one more cup of coffee, you have to hire a whole nother worker. Now to make 152, you have to hire like 2 more workers. You have to hire one worker that's just gonna like make sure the people aren't bumping into each other. You know, like it gets increasingly difficult. Think to the other examples are the corn example, where the average cost goes down at first because I'm getting better and more efficient and whatnot, but then over time, like to get to the outskirts of my property, to get the hose all the way out there, it costs more and more to try to squeeze out the last bit of corn from my property. I can rototill my driveway. I've already used all the good soil, et cetera, et cetera.
For this, does it assume that like the materials cost the same? For like if you're buying just one lemon, it could cost like $2, but if you're buying like 20 in bulk, it could cost less per lemon.
Yes. Yes. Like so. Remember that we're assuming one variable input. So we're assuming here that we have fixed costs that are set. Because the argument that you should make of why this wouldn't be the case is if you have a lemonade stand and you want to sell 1 million glasses of lemonade, build a new lemonade stand, build like 1,000 lemonade stands and have 1,000 lemonade stands that sell 1,000 glasses of lemonade, not one lemonade stand that tries to make 1 million. If you have 8 Starbucks baristas there, have 4 there, and build a Starbucks across the street or down the road like a mile and put 4 there. Right, that's what really happens. That's what when we start talking about long run and the fixed costs can change. We're assuming that there's only one variable input. That variable input is workers, and they have a constant wage. I use the other examples as just working examples. Also, on one of our first examples for T-shirts, yes, if we're to order 10 lemons, or to order 100 lemons, maybe I would order a case of lemons and get them at a cheaper price. If I wanted to order 1 million lemons, I might need to start my own lemon company.
Yeah.
And I have to worry about like importing them. Right? In the same way that if I want to buy 10 white T-shirts, I can go to Target and get 10 white T-shirts. If I want to buy 100, I can probably go to like 2 or 3 Targets or Walmarts and get 100. If I want to get like 500,000 white T-shirts, now I need to like drive around to a ton of places. Now I'm like spending a lot of gas, and now I need to negotiate with Hanes to like sell their shirts and Fruit of the Loom, or maybe I need to have my own. Like so again, the idea is that the returns are diminishing because I can't just drive 10 minutes to Target, buy a pack or 3 packs of T-shirts and have 50 T-shirts. That's a little bit of a contrived example, but it sort of gets that point. But again, the assumptions always important because where does this break down when we think of like, well, assumptions aren't always true. Fixed costs are fixed. Fixed inputs are fixed. We can't, for our Starbucks exam, or our coffee case study, we can't just have 8 workers, 4 here, 4 there. They're all in the one with one coffee machine. And that we only have one varying input, whatever that is. Everything else is staying constant.
What's an example of a fixed cost? I have an example of a variable cost.
An example of fixed cost: rent, insurance, machine.
Thank you.
If I'm planting seeds to grow corn, maybe my rototiller is a fixed cost, or whatever that machine is that like picks the corn. It's more than just a tractor. If you look at the chart or the table on the next page, calculating ATC, ABC, AFC, and MC, and that looks daunting, I would recommend that you check all of our notes, the reading, and the handout that all were assigned, etc., to get extra reps. If after 5 reps that we've had, assuming that you've done all of them, you're still struggling, you need to see me. If you don't produce anything, 0 boxes of oranges, there's no variable cost, because variable cost changes. And the total cost is 10. What's your fixed cost? I would go right to my average fixed cost and hit that column. 10 divided by 1, 10. I get the same thing. 10 divided by 2, nailed it. 10 divided by 3, 3.33, look, it did it for you. 10 divided by 4, so that's the 1, 2, 3, 4, 5th column. Done. Okay, total cost. We know the fixed cost is $10, right?
Yes.
So, all that the total cost is the variable cost plus 10. 30, 40, 70, 110.
Wait, where plus 10?
10's the fixed cost.
Are we doing ATC?
We're doing
Doing
total
ABC.
cost column.
With the wait, average total cost or average?
Just
variable
total cost, period.
The first blank column.
When I was in, I don't know, when did you do subtraction? 2nd grade? 1st grade? 3rd grade?
Subtraction's like, yeah,
That's
first,
like
first and second.
Okay, 1st grade,
See,
I
I
used to
was
get
like
like
third grade.
70% on my subtraction quizzes because of like the 100 problems. I would do like 1, and then 33, and then 22, and 94, and 6, and I would like miss 10 problems I just didn't do.
Why?
Why? I didn't see them. Because I just went all over the place. So that's why right then I just went and ran down the AFC. Because it was boring to just do 1, 2, 3, 4, 5. Think outside the box. Live a little.
Yeah, yeah.
You're only at once.
Right?
You're always young.
I wouldn't be as creative as I am now. And all of those things. Average variable cost. Average is just the total divided by the number. So it's just the second column divided by the first column. The coffee shop case study has the definitions of all of these. It's that divided by that. It's this divided by this. 20, 15, 20, 25. If you need help on those divisions, I think those are all ones you can do in your head. We did average fixed cost. Average total cost is the 3rd column divided by the 1st column, so we're looking at 30, 20. 70 divided by 3 is $23. And 30, oh, that one's already in there. Never mind. 110 divided by 4 is 27.5. Marginal cost. Here's a test. How ready are you? Marginal cost. Marginal cost is what and where do you get it from? Don't yell it out. Pick a lane, choose something, and then we'll talk through it.
Wait, did we do average total cost?
Yeah. Total cost divided by output. 30 divided by 1, 40 divided by 2, 70 divided by 3, 110 divided by 4. All right. Marginal cost, did you get it? 20, 10, 30, 40.
Nice.
Change in total cost divided by change in output.
Wait, what was the marginal cost? Again? 2010.
Change in total cost divided by change in output. So to produce the first box, it costs $20. To produce the second box, it costs $10 more. So to produce the second box, it costs $10 more. You have to invest $10 more to make the second box. You've already paid for the fixed costs, you've already paid for the first box. Then to make the third box, it costs $30 more. How come? Well, there's diminishing marginal returns, which means that
You should just produce the
as
same
variable resources are added, each additional output for each new worker will eventually fall. So if variable cost is like, it depends on how many workers there are, you have to hire way more workers to produce that third one. And then the marginal cost of producing the fourth box was $40 more. Assuming that this firm is in a perfectly competitive market and the price is $35 for each box, you bring in $35 for selling each box of oranges. Should you make the first box? Yes, it costs you $20. That's the marginal cost, the changing costs are making one more. It costs you $20 and you bring in $35. How about the second box? It costs you $10 to make that box. That's the marginal cost, but you bring in $35. Yep, you should produce that box. The third one costs $30 to make, and you can sell it for $35.
Profit.
Yes, you want to do that because you're making profit. How much, Chase?
$5.
Boom. What if it was only like $1?
We're still
Profit.
making a
Let's
profit.
do it, right? The fourth box costs $40 to make, and you can only make, and you get to make $35 for selling it. No. Firms should produce, so how many boxes? 3 boxes of oranges. Firms should produce as long as the additional revenue is greater than the additional cost. Additional is just a non-fancy way of saying marginal. Additional revenue, or marginal revenue, is greater than the additional cost, or marginal cost. To maximize profit, you produce whenever marginal revenue is greater than, up until when it's equal to marginal cost. At that quantity, the total revenue, 3 times 35, right? Because we're making 3 boxes. 3 times 35 is 105. Total cost, we just look at the chart, is 70. Total profit is total revenue minus total cost, 105 minus 70, which is 35. Let's say that in the perfectly competitive market, the price for each box of oranges was $8. The marginal cost is never above $8. You wouldn't produce anything. That's like what you see in this column that's crossed out, which is called the shutdown rule. Not on our test tomorrow, but what we're going to talk about on Monday. All right, here comes the big got-to-know piece. Draw a side-by-side graph showing a perfectly competitive market and firm. Draw the firm making short-run profit. This is half of the number ones on the free response of the AP Micro exam. Ask you to draw side-by-side graphs of a firm in a perfectly competitive market. I'm going to erase what I have up here.
So it actually makes sense.
Muscle memory. Let me give you some advice. Draw the market first. A firm is one tiny firm in the whole world of this market. If you want to have some boutique electronics store and you want to sell iPads in your store or iPhones, you have to charge the price that Apple tells you to charge. There's one price. You're one firm. The assumption is you're one firm. You can't make a difference in the price. You have no price control. You're what's called a price taker. You face a demand curve that's perfectly elastic. Your firm has the standard marginal cost curve. And remember, there's a ton of other firms that have the same marginal cost, and if you add up all these marginal cost curves, you get the supply curve, total supply curve. This firm is making profit. Well, here's where marginal. Why is this the profit maximizing point? Because the marginal revenue, which is the price that you get, if the going price is $35 for a thing of oranges, you sell one more box of oranges, you get $35. You sell one more box of oranges, you get $35. That's the marginal revenue. The marginal revenue is greater than the marginal cost. The marginal revenue is greater than the marginal cost. The marginal revenue is greater than the marginal cost at all these quantities until they're the same. And then the marginal revenue, how much you bring in, is less than the marginal cost. So you wouldn't produce out here. Here's your firm's profit maximizing quantity. This says that the firm is making a profit. Average total cost. This big rectangle, price times quantity, represents your revenue. Remember we did area on the back board there? Then, this is like the one leap, like this is logic, but average total cost, this is the average total cost, times the quantity, total divided by number equals average. Multiply both sides by number. Average times number equals the total. From the one time you were in kindergarten. Just kidding, it's probably like third or fourth grade, but my point is it's not like, we're not doing anything crazy here. Now from Algebra 1, multiply both sides by number. The quantity times the average total cost gives you the total cost. The average times the quantity, this box, gives you the total cost. Revenue minus cost.
Can you repeat what the big box is and the small box?
Revenue cost.
Average total cost?
The big box, the dimensions. Q, P. Q times P. Quantity times price. Total revenue. I'm pointing to the definition from the front page of total revenue.
Is profit always revenue minus cost? So it can be,
No, 2 weeks.
What would that be?
It should be like negative.
Right, and then that.
Because if the cost is
It's
out,
small.
if the cost is more than the revenue, then you're leaving money.
And then we'll get to like shutdown rule
Okay.
stuff.
I guess
That
whatever.
shows what the cost
I'm a bag.
is how you sell.
Are we gonna have to with these graphs tomorrow? Are we gonna have to put numbers on them and like calculate anything? Or are you just gonna tell us like draw like a perfectly competitive market firm graph?
You won't have to put numbers to them, but there could be numbers on one. Like if I gave you, so there's two, just to be clear, to reiterate, there's two free response problems. One is a firm's production, and yeah, that's gonna have a bunch of numbers, just like my soup example, the coffee shop case study,
So that'll give us something like this,
exactly.
and we'll have to fill out the chart and like know how to do everything.
And like explain some things, sort of like the top of this page, or maybe like the top of the back page, something like that.
Calculate the profit, what like
Yeah, it's gonna
like
be more quantitative.
when you should stop producing.
But then, and then the one for a perfect market is gonna sort of be like the one that I was describing about the Apple market at the end of class yesterday. On the front of this sheet, there's total revenue, accounting profit, economic profit, and normal profit. I told you I'd go back to normal profit. In a perfectly competitive market, economic theory, this is theory. In practice, no market is perfectly competitive. A perfectly competitive market has one price. How many products sell for one price only? Even at a farmer's market, you go down, there's lettuce at one spot, lettuce at another that are different prices. There's one price. There's one good. There's no differentiation of good. Like Coke and Pepsi is not perfect competition. Oh, Coke is a little bit sweeter, or Pepsi's a little bit sweeter, or whatever. Coke is a better decal. There's a ton of sellers, and one seller or one buyer can't make any difference. That's another assumption of the perfect market, and this is like the first page of chapter 14. That's not necessarily true if all of a sudden some cola company was like, hey, 25 cents for a 2 liter of Coke or a 2 liter of cola. It might take a while, but people might say, oh, cool. Or like a new video game console. Is that perfect competition between Sony, Nintendo, and Microsoft? No, someone else could come in with something new. But the idea, the theory, in one second, is that given that there's one product, given that there's one price, what's a smart person going to do here? They're going to say, oh, there's economic profit to be made. There's economic profit to be made. What should I do? I should get in on this. There's economic profit to be made. I should get in on this.
And then
That's going to increase the number of suppliers.
it's gonna take away the profit from everyone else.
It's going to decrease the price. It's going to change the quantity. And it's going to change the profit.
To only that little while.
And there's still some profit. See what's going to happen? Someone else is going to join.
Less.
So this is like the real world. Like this is what happens.
This is the theory of what happens
Theory of what
in
happens
the
in
real
the
world. Again, there's like rare to find a perfectly competitive market.
It's just one supplier.
So list in order what would happen in the long run. What's going to happen? Well, firms are going to enter to get profit. One of the assumptions of a perfect market is there's no barriers to entry. Again, page 1 of chapter 14 lists all of those. Every time I reference something in the book, that's like a wink, wink, nod, nod. Make sure that you've read that part. Wink, wink, nod, nod loses some of its mystique when you actually explicitly say it. So going back, normal profit is that there's zero economic profit. That what happens is firms are going to enter and enter and enter, and the market supply will increase and shift to the right. What happens to the price? The price goes down for both the market and the firm. Just like Bridget, goes back to answering your question earlier, and just as a like heads up to people that are here and a heads up to the people watching on the video through the World Wide Web. What would happen if demand changed?
If the demand went down,
everything-
Yeah, well, up or down, right? What's going to happen? Price, profit, etc.
It's all gonna be
Everything
affected.
Right? So when you think about what could be some sort of like, and I'm not saying that that's going to be the free response, but yesterday I gave you like an example of like Granny Smith entering the market, and then what happens? And then what happens? And then what happens? All these different things, and then the government sets a price ceiling. And the government sets up like so why is it cumulative? Everything from the second unit of supply and demand could impact this. I'm not going to ask will your profit change will it go down by $10 or $12? That's like not a question, but will profit increase or decrease?
With the demand change.
Right, so, like,
up and down.
Without getting into it, and you could do this on your own.
Who would you say?
You could say if there was a price floor or a price ceiling, what would that do to your firm? Right? You could think it and you could draw the different pieces. There's one piece that I think will help your understanding. And that's the lower right hand. Just be sure, right, market and firm. In the bottom left of the back page is a perfectly competitive firm making a loss. Hear me out. I drop $1,000 on equipment to make t-shirts, period. The squeegee, the everything there. Okay? Drop $1,000 on it. I find that the best price to sell my t-shirts at is $10. I also realized I can't sell enough shirts to make a profit. I'm not going to make money. But it costs me $3 to make each t-shirt. And I can sell them for $10. I want to sell t-shirts. I've already paid the $1,000. It's gone for the squeegee and the stencil. I can sell t-shirts for $10, and it costs me, say, $3 to make it. So I'm making $7 per t-shirt. I can only sell like 20 of them or something. It doesn't matter what the number is, as long as it's a small number. I should try to sell those t-shirts. Hey, I'm not going to make money. My fixed costs was a mistake. I shouldn't have spent $1,000 on a stencil. There's not enough demand for these t-shirts. But I can make some of that money back. Picking up what I'm throwing down there, I can make some of that money back. Can I make all of it back? No. I'm going to operate at a loss. I'm going to lose money, but rather than just, well, I lost $1,000 on the stencil, the design, and the thing, and the squeegees, I'm out, lost $1,000. Well, I can sell some amount of shirts and make $7 per shirt. I bring in $10, it costs me $3. That's the marginal revenue and the marginal cost.
A lot of businesses and restaurants, when they first open, operated at a loss for a while. It takes them a little while to get out of debt and make a profit finally.
The only issue, so 100%, long run versus short run. I'm operating fully in the short run.
Yeah.
Now, you're totally right that you could make, actually, you can argue that that's like an investment, that they're investing in the short run to make money in the long run. But firms can operate at a loss. What would happen? Here's my total revenue, but my total revenue is going to be less than my total cost. Here's where I produce. Does a firm a firm producing at a loss? The average total cost curve, and thus the total cost at the profit maximizing quantity, is higher than the price or demand curve. Same exact concept as a profit, except this is higher. So sort of going back. It's still revenue minus cost, except cost is bigger than revenue. So you get a negative number. We'll chat next week under what conditions you would shut down production, what conditions you would produce at a loss. But I think if you understand this, it's a good gauge for whether you understand the part above it, which is a firm maximizing or a firm making a short-run profit. I'd love to take questions, comments. You can hold alternative points of view.